So today in our discussion about electric charge, so before starting your discussion, I just tell you some concept about the basic concept of photon and your electron. So at first photon, you can already know this is P, or you can write in the form of 1H1. And in your electron, you can write E or minus 1 e to the power 0. So when you take, suppose you take a photon and a photon, you already know this is your like charge, so that it's form a repulsive force. It forms a repulsive force. Suppose this is what your F1 and this is also F1. Suppose you take electron, they are close to each other, so that this also a same characteristic force. This is your repel to each other, or your repulsive force is formed. This is your, suppose this is your F2. Suppose you take a photon and a electron, you can see here the force is attractive in nature. Suppose this is your F3. So you can say that in which the sum of these characteristics, including your photon and electron, that will rise the force, whether it was your repulsive force, or whether it was your attractive force. This property is called the electric charge. So you can see here the formation of electrostatic force. This formation of electrostatic force, whether it is your photons, whether it is your electrons, like charge and your unlike charge, advance or rise the electrostatic force, this is your electric charge. And including just one concept, I just tell you, you have already know the charge of the photon. You can write the charge of photon. You have already write 1.602 or 1.6 into 10 to the power minus 19 coulomb. The SI unit of charge. SI unit of charge. And you can write for electron in magnitude 1.6 into 10 to the power minus 19 coulomb. You already know this is your positive and this is your negative, so that the nature of the charge will be negative and it positive, but the magnitude here is also same. Suppose I just tell you one more concept, that's electric field. Suppose you take a charge. Suppose you take a charge, electric field. Suppose you take a charge plus q coulomb, and you take the another charge. Suppose this is your q1. When you take one charge towards this, you see here this characteristics of charge is same, so that a repulsive force is acting here, up to which when you take in this region, you can feel a repulsive force up to which this region is your electric field. Just I tell you concept of electric field. Suppose you take a charge and you take another charge in this region, so you can feel, suppose you take a positive charge, this is your repulsive. Suppose you take a negative charge, this is your attraction force. Suppose you take a uniform electric field, suppose something like that. I just discuss further. Suppose you take an electric charge, here is your photon. So the field in this direction, when you take a photon, your force will be in this direction, and when you take a electron in this electric field, the force is opposite direction, because you can see here the magnitude will be same, but the nature of the charge will be different. So when you take a charge in an uniform electric field, you see there the direction of force must be different, but the magnitude must be same, because this magnitude will be same. And your class, I have discussed the concept about your positive charge and negative charge electric field lines. I already tell you, when you take suppose a positive charge, the electric field line in diverge in nature. Positive Q charge diverge in nature. Diverge in nature. When you take a negative charge, this will be a converge in nature. Converge in nature. So you can see here, you already know diverge means one point to spread out in different direction. Converge means many, suppose you think the ray of light, many points meeting in one point. So if you take the concept about, suppose you take a positive charge and you take a negative charge, you can see here the imaginary line something like that. Suppose this is your divergent nature, and you can see here this is your electric field lines, this is your electric field line, something like that, and your direction will be, you have already know, positive charge in divergent nature and your negative charge in convergent nature. And if you want to draw a tangent in any electric field lines, you can get the direction of electric fields. So electric field direction is always positive to negative electric field lines. So when I tell you, if you take the positive charge and if you take the negative charge, the direction of the force in different direction. For your information, you can write this F equals to, suppose you take a charge Q, F equals to QE. That is for your just information. Suppose if you want to develop the same concept, when you take the magnetic field, this same type of concept will be developed. Here I am writing the static charge, positive and negative, and when you develop the magnetic field, you must take magnetic field, you must take the concept about current. And if you take a positive charge and negative charge, they are also in different direction, but the force is almost same. When you take, suppose you the magnetic field is acting here, and you throw a electron in the field of magnetic field. In this concept, you can just develop the concept F equals to, when you use the magnetic field, suppose Fm equals to Q V cross V, something like that force will be acting here. Just this is for your information purpose. So you can say here, when you take, whether it was a positive charge, whether it was a negative charge, due to this, including the, you have already know the electric charge, the intrinsic properties, somehow this way a advent or you can say the rise of electrostatic force. This due to this property is called your electric charge. So I can write here, it is the basic physical property of matter. Due to this property, a force is experienced. I am writing here, if you take a electric field, if you take a magnetic field, when kept in the field of electromagnetic field means electric field and magnetic field. You can see here, you can advance the concept about the force, whether it may be your repulsive force, whether it may be your attractive force. Okay, so that this is your basic concept. After that, we have discussed some property about electric charge. Some property. So we have discussed some property about electric charge. Our first discussion is basic property. Basic property of charge. Basic property of charge. So that I at first discuss the additivity of charge. So I have already tell you the charge in scalar in nature. Charge is a scalar quantity. Scalar quantity. Charge is a scalar quantity. So you have already know when we have deal in scalar quantity, it will be always follow the algebraic addition or your subtraction. Algebraic addition or your subtraction. Suppose you take a body. Suppose you take a body and you give the charge. Suppose Q1, Q2, Q3, Q4, okay, and suppose Qn, you give the charge. So total charge of this body, you can write total charge of this body, total Q1 plus Q2 plus Q3 dot Qn. So you can see here, you have already know the charge in a scalar in nature, so that when we dealing with scalar product, we have already get the magnitude only. So algebraic addition or subtraction always applicable. Suppose I can give you one mathematics. Suppose you take 5 charge. Suppose one is 1 microcoulomb, another is plus 2 microcoulomb, and another is minus 3 microcoulomb. Suppose you take 5 microcoulomb and you take minus 7 microcoulomb. So that the total charge of this body you can write in the form with nature plus 1 plus 2 minus 3 plus 5 and here minus 7. So you can see here plus 3 minus 3, 5 minus 2. So this will be negative 2 microcoulomb. Micro means 10 to the power minus 6. 1 microcoulomb, you can write 10 to the power minus 6 coulomb. So that you can see here total charge of this body will be minus 2 microcoulomb. This is your first additivity property of charge. In the next discussion, conservation of charge. Conservation of charge. I think you are most familiar with this concept and you have air, all of these things. Suppose you take the conservation of energy, you can see here also it can be created, not destroyed, something like that. So I can write here in the short form, for isolated system, for isolated system, total charge must conserved. Total charge must be conserved. Suppose I just tell you, when you deal with thermodynamics, this time thermodynamic system means it does not exchange the matter or energy. But here in the concept of electrostatic charge, so you can dealing with, you can take more concept about isolated. I think this is insulate, something like that. Suppose you take a isolated system, that means in the surroundings, if it is not affected in this system. Suppose you take it 2 charge plus 2 coulomb, and you take another charge is plus 3 coulomb, and the effect of the surroundings is not acting here. Okay. After that, suppose you want to transfer 1 coulomb here. Suppose you want to transfer is 1 coulomb here. At first, your total charge will be at first 2 plus 3, so 5 coulomb. After that, suppose you want to transform of 1 coulomb is here, so that after that your charge, this is your first and this is your final, also the same. When you one increase here, so that this is your plus 1 coulomb, and this is your this is your microcoulomb, same unit microcoulomb, so that 1 plus 4, this is also the same plus microcoulomb. So you can see here, for your isolated system, before the condition and after the condition, the charge must be same. Suppose you think about your nuclear fission and your nuclear fusion, where you can see also the same equation like that, 92 to 35 plus 0 N1. Suppose you take an isolated system, you can write your barium and your krypton, something like that, and 30 N. Sorry. Okay, so this is your 56 and your 36, 141, and this is your 92 krypton. So you can see here total charge is here 90 plus 0, 92, and you can see here 56 plus 36, also 92. So before and after, charge will be conserved. Okay, this is your nuclear fission. If you take the nuclear fusion reaction, this is also you dealing with the hydrogen and release some energy. Here your energy is something like that, 200 MeV. Okay, mega electron volt. So you can see here the total charge of this system must be conserved. Charge cannot be created or destroyed. It only transfer. Okay, this is your second concept. Okay, we move further in your last concept of quantization of charge. Quantization of charge. Quantization of charge. Suppose I tell you oxygen atom. Okay, so oxygen, this is your plus 80. Sorry, I just write it in photon number, and this is your electron number minus 80. So atom, it will be neutral. So number of your positive and number of your negative will be same. Suppose I give you 1 electron here. I give you 1 electron. So that this will be transformed minus 9 coulomb, and the charge of the body is 1 coulomb. Suppose I give you another charge. Suppose I give you 1 coulomb, so it's become minus 2 coulomb. Okay, so that the body, charge body is minus 2 coulomb. Suppose I take out 1 coulomb. 1 coulomb, this value is 7 electron. Sorry, 7 a positive number. So this is your 8, 7, and this is minus of 8. So this was plus of E, something like that, your concept. So when you take out, when you are giving, so concept is something like that. Sum of this here 0 minus e minus 2 is plus 1e plus 2 is something like that concept is also developed here. So that in our discussion here, I just tell you one thing that we cannot, suppose you take here in the packet form, transfer of charge in packet form, you cannot say this, you can transfer of charge is 1.5 electron. 1.5 electron. You cannot transfer of charge in the form of fraction. You cannot transfer of charge in the form of fraction. Suppose at first in our concept you must know E is the elementary charge. Elementary charge. Elementary charge means it is the minimum charge. So you can write, when you write in the photon, this is also your plus E, and when you write in the electron, this is also your minus E. E is here value of 1.6 into 10 to the power minus 19 coulomb. So the quantization of charge, something like that, you cannot transfer. You cannot transfer the charge from one body to another body in the form of fraction. You cannot transfer. You can transfer one electron, you can take 2 electron, you can take 3 electron, you can take plus E plus 2 is something like that, but you cannot transfer in the fraction form. So you can finally write this concept. So you can finally write this concept. All the observable charge or possible charge are always the integral multiply of elementary charge. So I just write out in the possible charge or transferable charge or observable charge, something like that. Q equals to plus minus of your Ne, where n is integer. So you can see here something like that 0 is a minus 1e plus 2e, sorry, minus 2e plus 1e plus 2e, something like that. So you can see here you cannot the transfer of charge in the form of fraction. So I just you have already know in our modern concept we have already dealing with the concept about quark particle. Quark particle. So I have already tell you, when you take the charge, concept about charge, you take the smallest charge is the charge of 1 electron charge, that's a fundamental charge, but the concept is developed somehow in the modern concept. You have already know the quark particle, the charge of the quark particle is the charge of fraction in form. When you take in the quark particle in up and down concept, up and down concept, you can write here in your up concept 2 by 3 of E and 1 by 3 of E. You can see here this is also a fraction form, but you are on mind that these are not staying in the free state. These are always in the combined form. These are always in the combined form. So this is also gives the integer. So far you have right, when you transfer of charge, the charge must be the integer, it is not in the fraction in form. Suppose I give you one example, one mathematical example. Can a charge of suppose can a charge of 8 into 10 to the power minus 18 coulomb be given a body? It will be possible so far. Can a charge of 8 into 10 to the power 8 coulomb be given a body? So you can just check it. Equation Q equals to N. So your charge is 8 into 10 to the power 18, and your charge of electron here 1.6 into 10 to the power minus 19 coulomb equals to N. So you can check here 8 1.6 into 10 to the power 10 to the power minus 18 plus 19 equals to n. So you can see here n is equals to this, that gives you 10 to the power 1. So 10 is here, 8 into 10 into 10 by here 16. Okay, so 8 10 to the 10 to the power 1, take it 1 by 10 10 16 16. So you can write just 8 into 2 2 of 5, so 50. You can see here n is 50. You can get n is 50. So 50 is the integer, n is integer, so it will be possible. So it will be possible. Suppose n is coming 48.8. This will be not possible. Only possible when n is coming in integer in form. Okay, at the end point, I just added some portion, some unit. I have already tell you the unit of charge in SI, charge in SI, and this here is Coulomb. When I used in CGS, you can write stat Coulomb, or you can write ESU. Okay. So this is our end of discussion, and I just added some portion. Suppose I just tell you when the charge is transferred, you have already know mass also be transferred. So I just give you one example. Charge can exist. Charge can not exist without mass, but mass can exist without charge. I just tell you just one simple concept. Mass cannot, charge cannot exist without mass, but mass cannot exist without charge. Suppose this simple concept, you take the neutral body. So you can see here number of photons and number of electron must be equal, so that your charge will be 0, but mass almost you have already know mass of electron and your photon also. So I just tell you one more concept, just added one more concept. Charge is invariant, but mass is variant. You have already know when a body is moving in the speed of light, this time your mass equation something like that, m naught by root over of 1 minus v square by c square, when the velocity of the body is the velocity approximately the velocity of light. This time this was a rest mass. Your mass will be vary, but your charge will be invariant. Okay, and this comes from Einstein equation, and hope you will understand. Thank you very much.